compute conditional probabilities. Key word here is conditional. Now, when you are dealing with conditional probabilities, that means given something else is true. So how does that impact your probability? So our formula, the probability of A given B, right? So you're either going to see the word given or the word if this happens. So these are the big ones that claim, okay, pretend this happens, right? One thing happens, how does that change, right? What is the condition of your probability? So the notation for A given B looks like this. Probability of A given B. So it's like this line between A and B. And we find that by taking the probability of B and A all over the probability of B. All right, so this is what we're going to do. Okay, let's do some examples. There are 300 junior high students who are asked about their favorite subject. 47 said math, 72 chose history, and 12 actually said they like math and history. Given a student likes math, what is the probability they also like history? Okay, I'm a big fan of writing this out. So the probability of, given a student likes math, probability they like history. So probability of history given they like math. Now you might say, well, why does this matter? Well, I'll tell you why it matters. In the formula, notice that it's A given B, but look at this. I mean, B and A and B kind of the same, but it really depends on what you're dividing by. So if it's given that we like math, then we're going to divide by the probability of math, right? Okay, so let's write this out in symbols. Probability of history given math. So that means we're going to find the probability of math and history and divide that by the probability of just math. All right, well, based on our problems, we have 300 total. That's going to come into play. And 12 said they like math and history. So there's that. So my numerator is 12 over 300. And then what's the probability of just math? Well, 47 out of 300. And now we have a complex fraction, right? A fraction over a fraction. Remember that a fraction bar is a division sign. So this is the same as 12 over 300 divided by 47 over 300. And do you remember how to multiply fractions? We keep the first fraction. We change fraction to multiplication, division to multiplication, and then we flip the second one, right? So you multiply by the reciprocal, or keep, change, flip is kind of the nomenclature that a lot of young people learn. Okay, so my 300s kind of cancel out, which is nice. And I'm left with 12 over 47, which simplifies to 0.2553 as a decimal. So about a 25% chance that if a student likes math, they will also like history. All right. A standard deck of cards contains 52 unique cards representing 4 suits, hearts, spades, clubs, and diamonds. What is the probability of pulling a 4 given that the card is a spade? Okay, so probability, probability of pulling a 4 given that the card is a spade. Now, you're going to notice, hopefully you'll notice at some point, some patterns with this. So this is the probability of a spade and a 4 over the probability of spades. So working through this, what's the probability that you pick a spade and a 4? Well, there's only one of those. So 1 out of 52 cards. Now, what's the probability of pulling out a spade? Well, there are 13 spades out of 52 cards. Because 52, 4 suits, there's 13 each of each suit. So going through this just like we did, right? Because fraction is division. And then we change division to multiplication and we flip. Notice what happens again. My 52s cancel out and I'm left with 1 over 13. So I want you to think through this. When it says given that the card is a spade, that means how many spades are there? 13. That's going to be our denominator. So whenever something follows given, that's going to be your denominator. Okay? Worked the same in this example. Given like the student likes math. Well, 47 like math. Look at my denominator. 47. Okay? Because when it says given that, that's what you're going to do. That's what you're using. I say that because when we're doing and working with a table, it makes it a lot easier to follow that mindset. So we have students wearing glasses, yes or no, and then we have what color of shirt are they wearing, red, green, or yellow, given in this table. So we're going to find the probability of a red shirt given that the answer is yes. Okay, so using our process of saying, given that the answer is yes, meaning we only care about yes answers. So that is this top line. How many students said yes? 21. So that's going to be our denominator. Because yes, so whatever's given, that's what's going to go in the denominator, and then the number of red yeses go in the top. Because remember, the top is the probability of this and that, right? That was in our formula. So, just to give myself some room here, looking only at the yes line, how many reds are there? Well, there are 4. So my numerator is 4. So given that the answer is yes, to glasses, probability of a red shirt, 4 out of 21. And that should hopefully make sense because they're saying, okay, you know, a kid dropped their backpack. Well, what do you know about them? I know that they were wearing glasses. Okay, so given the kid there's 21 kids with glasses. I think they're wearing a red shirt. Okay, 4 out of, right? So this is the idea that we're going with. We're only looking at the 21 kids with glasses to see who dropped their backpack. Okay, the second one. Find the probability of yellow shirt given that they do not have glasses on. So now we're given no. That means no is in the denominator, and then the yellow no is in the numerator. So how many students said no? And that would be 17. In that circled line here, how many yellow shirts are there? And that's 2. So 2 out of 17, which gives me 0.1176 as a decimal. And the last one, find the probability of yes given green. So now green is in the denominator with yes in the top. So now we're going this direction, and we're playing with the green line. There are 13 total green t-shirts. 7 of them are a yes. So 0.5385. And that is playing with conditional probabilities.